And I'm going to give you a bunch of Post-its so that you can write down on separate Post-its all the different things you need to make a light bulb light. And how to make your light bulb light. That's your activity today, is how you're going to make your light bulb light. We're physically working with light bulbs. So I just want to get you started on some of those strategies, because our aim is to understand how circuits work. We've got an introduction to open and closed circuits. So I'm going to just kind of write down the unique things. And we're going to play around with that in an activity today called Crack the Circuit, which is another fun game similar to, I think it's more fun. It's similar to the kind of electric field hockey game that you played yesterday. So open and closed circuits. Okay, so we've got electricity through a filament, which another group put this down. I'm going to write down as a conductor, because a conductor is a definition that we know what it is. It allows electrons to travel through. We've got speed of light. Now, with a light bulb, yes, there's speed of light, but the speed of the electrons is kind of dependent on the electric potential energy. Needs conductors. Yes, it does need conductors. And in order not to electrocute yourself, we've also got insulators. Prevent electrocution and prevent fire, right? So we've got a lot of similarities. Current. And we're going to talk about the definition of current, but the current is how fast electrons travel. And we're going to talk about how battery works to give you a little introduction as to how they work. I saw something, wires. So wires are comprised of conductors and insulators. Again, relating to the fact that we don't want to electrocute ourselves or cause fire in our homes. So we've got resistance. Electrons. So when we talk about current, it is the transfer of electrons. Ooh, I like this one. A full or complete circuit. And that's going to be one of the key things that we want to know. A difference in voltage. So when we talk about a potential energy, voltage difference, we're really talking about voltage. Voltage is our unit for energy, and it is the amount of energy that is stored. In order to have electricity, we need to have that energy transferred, and that's what we call our voltage drop. Resistance is actually our light bulb, but we'll talk about that in a little bit. Has to be closed. Flows from positive to negative. So we're going to learn about a battery and answer this question. We've got charged particles, and that's how electrons are able to flow is if there is a charge. So, do I have electrons somewhere here? Insulations, transfer of electrons, charged particles. Energy source. Electrical current. We already talked about current. Someone mentioned batteries. Ooh, we have direct and alternating currents. We're not going to get into alternating currents too much, but there are different types of current that we use in our households. I think we covered everything. So these are an introduction to some of the things you want to think about when you're creating the challenge in your individual bulb and battery activity. But we talked about electric potential. We talked about, someone mentioned a voltage difference. I want you to learn in this next video how batteries work to create electricity. So
whenever we use an electrical,
let me just make this a little bigger. And then
device that's not plugged into the wall, we have to put a battery in it. But how exactly does this tiny little cylinder allow technology to function? To understand this, first we need to do a quick refresher course on what electricity is. Now, to keep things very simple here, think of an electron as a single unit of electricity. If an object has a ton of electrons in it, it has a lot of electricity in it. Electricity follows this simple rule. If there are a lot of electrons in one object, and very few electrons in a different object, the electrons want to go to the place with fewer. Why electrons behave this way is very complicated, so I won't go into it now, but it's a simple rule of physics, just like gravity. So if we connect the low charge and high charge objects together with a conductive material like copper, the electrons will flow from one to the other. The process of electrons moving across this wire is what we call electrical current. Now, if we run this electrical current through certain types of materials, they can make it glow or heat up or make things move. So with this basic concept, electricity can light a light bulb or turn a motor or operate the tiny little switches that make computers work. So the question is, how do we get electricity where we want it? So we know that copper is a conductor, which will allow electrons to move through it. But other materials like rubber will not allow the electrons to travel through them. These materials are known as insulators. With conductors and insulators, we have everything that we need to make a battery. This is what the inside of a battery might look like. In this battery, the blue section is a material with very few electrons, while the red is the part with a ton of electrons. The reason the electrons aren't flowing is because they're separated by an insulator. That's everything you see in brown. The electrons have no way of knowing that there's this desirable low electron material nearby. Now the gray part is the conductor. If we use some conductive wire to connect the front conductor to the back conductor, the electrons have a path to get to where they want. So if we want to power, say, a light bulb and a flashlight, all we have to do is make part of that path composed of the filament of the light bulb. As the electrons run through the filament, it glows and is amplified by the bulb, which means the flashlight is now on. Making an on and off switch for the flashlight is simple. We make a small part of the conductive path that the electrons take removable. When you flip the switch off, the conductive path is broken and the flow stops. When we flip it on, it continues. The switch is simply completing the circuit from the front of the battery to the back of it. This on and off switch here is the fundamental principle behind how all buttons, switches, touchscreens, and really anything electronic and interactive functions. Let's take a look at what happens when you press a button on a Game Boy. Just like with the flashlight, the internal circuitry of the Game Boy has these incomplete circuits in it, and they're completed when you push the button down. It's arranged in a way so that when this circuit is completed, it sends the electrical signal to the CPU of the system, where the flip-flop switches are changed and the thinking process occurs. This is how all inputs into all computer systems work, at least in some fashion, by completing circuits which send electricity to certain nodes in the CPU, which it understands as whatever it's programmed to understand. Touch screens use this same system by using the oils in your fingers to complete circuits which lie just under the screen. When those circuits are completed and current flows through them, the computer knows that that part of the screen is being touched. While the basic concept of completing a circuit is more or less universal to the process, there are a ton of different methods used to accomplish this and of how to achieve the desired results afterwards. Other topics related to circuitry include things like resistors, capacitors, and Boolean logic. If you have any interest in these topics, you can let me know in the comments, and as always, liking and subscribing and sharing are a massive help.
All right, so I was kind of going through and starring some of the things that they talked about that you had already mentioned. So when you have a battery, you have this buildup of negative charges on the positive side of your battery, and you've got this conductor in the middle that can attract those negative charges, but it needs a place to travel there. And so this part of your battery, your positive side, and this part of your battery, the negative side, allow the charges to travel only if you have a closed circuit. Having open circuits is helpful because if you want to turn your light bulb off, then you can just stop that path of electron flow. Now, we used to call batteries, when we were talking about the energy unit, we used to call them chemical energy, right? Because we didn't want to talk about electric energy because we hadn't learned about it yet. Well, what happens in the battery is a chemical reaction that continues to build these electrons on the positive side, and that chemical reaction, even if you have a closed circuit and all the electrons start flowing into the negative, it keeps continuing to build that negative charge. So that's why your batteries it does end up running out of charge, but it works for a pretty long time because that chemical reaction continues to build the electrons on this positive side. Now, we talked about conductors and insulators. You've got wires. Notice how there's metal clamps on the end, so you're going to use these to connect it to your battery and your light bulb, but it is covered in rubber, which you stated was an insulator. And I love this video because now with technology, we, with our cell phones, we take the fact that our body, or more specifically the water and oils in our skin, are conductors, and that can even create a closed circuit when you're playing around with your iPhones and your touch screens, which is a really cool technology, very innovative compared to when we actually had to have, buttons on our phones and they were really massive. Questions?
Batteries. Is why take a dead battery out of the whole power device and leave it for a little bit and then
Because it builds up a little bit through that chemical reaction. I mean, it's not going to work great once it dies. Yeah. So you're going to, now that you know how battery works, you're going to play around with the battery. I didn't talk about the anatomy of a light bulb, but I want you to experiment with it. The light bulb has some specific characteristics that are going to be important for you to observe before you get into this lab. But I want you to try to figure it out through just experimentation and process of elimination. And then we're going to review that knowledge before you get into the homework, because the homework is focused on light bulb anatomy. So I want to make sure that you get that understanding by playing around with these. So everyone is going to grab one kit. I have a stack of kits in the back with wires and batteries and light bulbs. The light bulbs will burn out. I don't know if they handle the 9-volt batteries very well, so if they do, I've got tons and tons of light bulbs if you need it. And the activity, let me get out of this, is on Canvas, and it's very similar to what we did last class, where one person is going to open it up. You're going to share the Jamboard with everyone in your group. You're going to play around with your setup. Let me make a copy. You're going to play around with this setup, and then you're going to draw what you came up with once you were able to make it work. So each slide is going to give you a challenge. It says you have 1 battery, 1 light bulb, 2 wires. How can you light up your battery, and provide an explanation? Each of these you're able to move around, twist, and move around as you decide to. And then you've got this pen to draw how your wires are going to be connected, what you think you're going to need to do to make it connect. Obviously, I gave you the wrong answer, so I want you to determine where those wires should specifically be placed. I don't want you to do it kind of like willy-nilly the way I did, because I'm going to look at where your wire starts and where it ends when it touches the battery, and where it touches the light bulb. So those are the things you're going to play around with when you're doing this experiment. And then it gets more challenging. It starts with 1, goes to the next, where you can have multiple answers to create the same result. And then once you are done, you're going to share this URL with everyone in your group, and you're going to submit it on Canvas as you did last class. The next activity is a fun game. It's actually super fun. And everyone's going to do it individually, but you have to understand, it's called Crack the Circuit, and you have to understand what each of these symbols mean before you get into it. So you're going to have symbols like this, and it might be intuitive to some, but I want to make sure to go over them. So you read the directions on Canvas carefully. It'll tell you how to set this up, but I'll show you all this next. But they're going to give you a battery, which looks like this. This is our symbol that we're going to use for batteries when we draw circuits. It's going to have a light bulb, and you're also going to have a switch. So your switches, or your symbols for those, are going to look like this. Battery, positive to negative. The light bulb kind of looks like the filament in a light bulb, and then the switch is pretty obvious. It has that little door that opens and closes to create an open and closed circuit. And then your wires you're just going to draw in, and you're going to erase them by just kind of sliding backward into those slides. So there's a bunch of levels. You're going to play around with it. I want you to get through the first 9, I think it's the first 9 levels, and then try one of the first 8 levels, and then try one of the levels 9 through 18. And then if you send me a screenshot, then I'll give you the points for it. So you're going to submit your screenshot through Canvas. I find that students, when they do this, they end up really having a lot of fun, so they just continue doing all the levels. But I want you to get through light bulb first, bulbs and batteries activity first, and then you can all grab a laptop and you can start working on this individually. So before you leave, I want to make sure that you understood the concept behind how to create, or how to get your light bulb to light using a battery. So that was basically our bulbs and battery activity today. So what was the main setup to get your light bulb to light? What was the key thing that a lot of students had to play around with to figure it out? Obviously, this one wasn't a challenge. We needed the wire to go from the positive and then to the negative. But how should it connect to the light bulb? That was the most difficult part of this. How should it connect to the light bulb? Emily.
One clamp was on the side and one was on the bottom.
So if you noticed, we had metal at the bottom and metal on the side. Those are conductors. Whereas around that metal, there was a black insulator. So what that shows you is that as it goes through the filament, remember we have to make a complete circuit. So the bottom conductor, that metal piece on the end, connects to one side of your filament. It goes through all these little loops. And then the other side connects to the conducting coil. That kind of screw that allows you to connect your light bulb. So the fact that that's metal and this is metal is key to a light bulb anatomy. Because if you had the filament connecting to the same end, or if they both went through here, this conductor would allow the electrons to flow through this complete conductor and not through the filament. And we need to make sure that we go through one side and the filament that way and then out the filament the other way. We can't close the loop here. Otherwise, the electrons are just going to pass through the path that has least resistance, which is this guy. I haven't talked about resistors yet, but that is a resistor. And so in order to make sure it goes through the resistor, we need to make sure it goes through the bottom conductor and out the coil conductor, or that screw conductor. All right, questions? Okay, I know you played around with it, but that was the main thing I wanted you to get out of it, to do your light bulb anatomy assignment tonight. And then you're doing some reading, but you need to complete the front page of your reading packet. So 3-4-1. And that's it.